Hello, welcome to the Tall Building projects. This is the problem statements by the Skyfi Labs. I will show how to make this project in ETAP software. Open ETAP software. This is the evaluation version of ETAP. Then OK. Open new project. Set all the data as shown. Then click OK. Give the number of grid line in x and y direction, that is 4, and spacing of grid in x and y direction, that is 6. So change it. Number of story, that is 23, and the typical story height and bottom story height, that is 3. Then click custom data story, then edit story data. He will set that the master story is set to 23, but we need to change all. From story 1 to 8, the story 8 is the master story. So change it and change the story similar to story 8. Then from story 9 to 14, the story 14 is the master story. So change it and change the story similar to master story 14. Then from story 15 to 19, the master story is story 19 as shown in the problem. So change it. So change the story similar to story 19. From story 20 to 23, it is already mentioned that the master story is story 23, so no need to be changed it. Click on OK. Then click on grid only. Then click on OK. The graph of the building is shown in plan view and 3D view. This is the 3D view. Then click on define. Then section properties, material properties. Then add new material. Select region as India. Material type to concrete. Standard to Indian. And grade to M40. Then OK. Then OK again. Then add new material. Change the material type to rebar. And grade to HOSD 500. Then OK. Then OK again. Add new material. Change the grade to mild 250. OK. Then OK again. Then OK to exit. Then define section properties. Then select frame section. Then click add new property. Click on rectangular section. Give the name of the column to column 500 into 500. Change the section dimension. Then go to modify slash story bar. Change the longitudinal bar to HYSD 500 and confinement bar to mild 250. Then OK. Then OK again. Add copy of property. Give the property name to column 550 into 550. Change the material type to M40. Section properties change. Then go to modify slash story bar. no need to be changed here. Then OK, then OK again. There was a mistake in my side, I'll be corrected it. Modify slash story property option, change the material. I am not given in the material type M40. Then OK. Then add copy of property, change the property name to column 600 into 600, change the section dimension, then OK, then OK again. Then add new material, auto select section list, change the property name to column auto select, auto select column, change the design type to concrete, select all column section, then add, then OK. Then add new property, change the section to concrete rectangular, change the property name to beam 500 into 300, change the material to M40, change the section dimension, then go to modify slash sorry bar option, change the design type to beam and longitudinal bar HYSD 500 and confinement bar mile 250, change the clear cover top and bottom both 25 mm, then OK, then OK again. Add copy of property, change the property name to beam 550 into 350, change the section dimension, then go to modify slash rebar option, no need to change, OK, then OK. Then add copy of property, change the property name to beam 600 into 400, change the section dimension, then OK. Then add new property, go to auto select section list, change the property name to auto select beam, select design type to concrete, then all the beam sections selected, then add, then OK, then OK again. Then go to define section properties, then select slab section, select add new material property, enter the property name to slab 150 and slab material to M40, thickness will be changed 150, click on OK to exit. In the plan view, go to story 1 by the help of arrow keys. Change one story to similar stories, all stories. Then go to quick draw column option, then select auto select column, then select the grid areas, then quick draw beam option. Here the property is auto select beam, then dragged all the grid line, then quick draw slab option, property will be slab 150, then dragged, slab will be created. Using arrow key, go to the any of the story from 9 to 14. Same procedure will be done, but the required areas will be different. quick draw column option, then drag the required area, then quick draw beam option, select the required area, then quick draw slab option, select the required area, then go to story 15 to 19 by the use of arrow keys. Same procedure will be done here, but the required areas will be different. To story 20 by the use of arrows. Then select one story option here. Then same procedure will be here. The required areas will be different. Then select the total selected area, then go to edit menu, then replicate, select the story tab in the box, then select 21, 22, 23 together, then click on apply, then OK. Then go to story 1, use the arrow keys, then select all stories option here, then select all the cells, select the cells one by one. Then go to assign, then cell loads, then click on uniform, set the load pattern name to dead, then the value as 2 kN per meter, then apply, then OK. Then go to similar storage option, then select all cells one by one, then go to assign, then select cell loads, then select uniform, change the load pattern from dead to live, and the values will be 5 kN per meter square. then apply, then OK. Then go to any of the story 9 to 14 by the help of arrow keys. Then select all the cells one by one. Then go to assign, then cell loads, then uniform. Change the load value, live load value to 4.5 kilonewton per meter square. Then apply, then OK. Then go to story 15 to 19 by the help of arrows. Then select all the cells one by one. Then go to assign, then cell loads, then uniform. Change the live load value to 4.4 kilonewton per meter square. Then apply, then OK. Then go to story 20 to 23 by the help of arrow. Then select all the cells one by one. Then go to assign, then cell loads, then uniform. Change the live load value to 3.5 kilonewton per meter square. Then apply, then OK. Go to story 1 by the use of arrows key. Choose the similar stories option. Then select only the outer beams. Carefully, only selected the outer beams. Then go to assign, then frame loads. Click on distributed. Enter the uniform load value to 0.2 kilonewton per meter. Then apply, then OK. Similar procedure will be here. Go to story 19 to 14 by use the arrow key. Then go to display menu, on deformed shaft. Keep the similar stories option. Keep it. Then select the outer beams only. then go to assign, then frame loads, enter distributed, enter the uniform load value to 0.2 kilonewton per meter, then apply, then OK. Similarly, then go to story 15 to 19 by the help of arrows key. Go to display menu. No need to be selected the display menu, only select the outer beams on the required areas, only selected the outer beams. Same procedure will be here. Then go to assign, then frame loads, then distributed, keep the values as 0.2, then apply, then OK. Then go to story 20 to 23, any of the story between them. Select the outer beams. Same procedure will be here. Then assign, then frame loads, then distributed, keep the value 0.2, then apply, then OK. Then go to last story option, that is story 23, using the arrow keys. Change the similar story to one story. Then select the external beam only, the story 23. Then go to assign, then frame loads, then distributed. Choose the option delete existing load, then apply, then OK. Now go to the base by the use of arrow keys. Go to display menu, on default shape, keep one story option, then select the total grid, then go to assign, then joints, then restraints, keep the fixed option, select the fixed option, then OK, apply, then OK. Then go to draw menu, then auto draw cladding option, select the floor, use floor option, then click on OK. The cladding will be created. In 3D view, you will see it. Then go to define, then select load patterns, type the load name as wind, select the load type as wind, and in auto lateral load option select IS875 1987, then click on add new load, select the newly added load and select modify lateral load. Enter the wind speed value as 33 meter per second as per the code. Then select terrain category as 3. Then select the structure class as C. Take risk coefficient factor as 1 and topography factor as 1. Then click on OK. Then click on OK. Click on OK again. Click on elevation option. Select the elevation side for A, then OK. Select one story option to all story option. Then select all the cladding cells. Then go to assign. Then cell loads. Then wind pressure coefficient. Change the coefficient value to 0.8 plus 0.8. Then select the windward option. Then apply. Then OK. Select the elevation option. In the 3D view, I'll show you how to see in it. Go to elevation option. Then select section B. Then OK. Select all the cladding cells. Then go to assign. Then cell loads. Then wind pressure coefficient. Keep the values as 0.8 and windward option. Then apply. Then OK to exit. Then select plan view option and select story 1. Then OK. Here you will see the wind pressure will be acted. Then go to elevation view. Then selection D. Then click on OK. Select all the cladding cells with all storage option activated. Then select assign. Then cell loads. Then wind pressure coefficient. Then enter the values as minus 0.25 and select the leeward side option. Then apply. Then OK. Then go to the elevation view section. Then selection C. Then OK. Then select all the cladding cells. Then assign. Then cell loads. Then wind pressure coefficient. Change the values as minus 0.25. Apply. OK to exit. Then select elevation option. Select 1. Then OK. Then select all the cladding cells. Using arrow key, move to elevation view 2. Then select all the cladding cells. Then move to 3. Again select all the cladding cells. Then move to 4. Again selected all the cladding cells. Then go to assign menu, then cell loads, wind pressure coefficient. Change the values as -0.8. Keep the leeward option, then apply, then OK to exit. Then go to plan view option. Select story 1. Then click on OK. Here we will see all the wind pressure will be acted. Different room, all the room will be acted in wind pressure. I will show you. Here the story 19. Here will be acted. Click on OK to exit. Select the 3D view tab. Then select use extrude view for frame object. Then go to analyze menu, then run analysis. Before analysis, it will save some name. I'll save it final project building. Save. It will take some time to analyze it. The displacement will be done. In 3D view you will see it. Then go to design menu, concrete frame design, start design and check. It will take some time. Here the 706 concrete frames will be filled. I will click yes. It will again redesign, because I have selected auto select concrete or auto select beam. Which section will be failed? The auto select option will be extend into next higher value. Here the done. The design will be done, the checking will be done. Verify all member passed. Here the all member will be passed. Click on OK. Then go to design menu, then detailing, calculate rebar detailing. Here the detailing will be not done because this is the evaluation version. The detailing part will be done only in the licensed version. Then go to the reports. I will select the summary reports. It will also take some time. Here the summary report will be there. All the details will be here: the reinforcement details, the rebar details, the concrete details, all the details: displacement, reinforcement, shear force, bending moment, all the details will be here. Then go to project report. I'll select. It will also take some time. Here the project report will be successfully produced. All the details will be here: shear force, bending moment. Here the longitudinal reinforcing details. I'll see it. You also see it. Zoom in, click any point, will show the reinforcing, longitudinal reinforcing details. This is the online project given to me by the Skyfi team, and I will be done it. So thank you so much.